Lecture 10, Lie bracket and covariant derivative relationship. In the previous lecture, 9c, we derived the Lie derivative, okay, starting from the definition. Now, Lie bracket definition, coordinate free. Given two smooth vector fields x and y on a manifold M, the Lie bracket, you see x, y, is another vector field defined by this relation here, okay, that we derived in the previous video, 9c. In words, it measures the difference between moving y along x and moving x along y. That's what means the Lie derivative. Now, let's move to covariant derivative. Nabla xy, the covariant derivative of y along x, written Nabla xy. In general, you see in the literature, you see it is using capital D instead of Nabla. You see, the xy is a way to differentiate in the direction of x, y, respecting the manifold affine connection. Connection, it means when you say connection, you always have to relate to Christoffel symbols. In the flat space, Christoffel symbols, they are zero. Now, let's compute this covariant derivative, Nabla xy. By the definition of the covariant derivative in coordinates, you see Nabla xy is xi, Nabla y, where this Nabla y, this y, iy, is partial derivative of yk, partial xi, this is basis vector, partial xk, plus the Christoffel symbols yj, the basis partial of xk. So this is a covariant derivative here. Now you can put here all together. You see here that Nabla xy, xi, you see that's a repeat from here to there. This is partial derivative of yk xi, Christoffel symbols yj, and the basis vector partial xk. In component form, you see, you just from here we obtain the components, okay, which I denoted as Nabla xy at k is xy partial yk xi plus xi yj gamma ijk. So these components of this covariant derivative. Analogous, you just substitute, you see x by y, and copy from here to here this yk, this xk, this xi, this yi, this yj, this xj. Now, gamma jik, Christoffel symbols. You see the difference? Here is gamma ij, here is gamma ji. Now, let's subtract, okay, the component forms, okay? Just this leads to the right-hand side. You just substitute in the, you see the difference here and put all together. Now, compare now with the Lie bracket. You see the Lie bracket as we derived as a consequence of the definition of the Lie derivative, as I emphasized on previous videos, previous lecture, 9c. You see the Lie bracket, it just can written this form over here. So you compare, you see clearly, you compare, you see, you plug this there, this is the Lie bracket plus this part over here, you see. So this is quite easy to see it. So next lecture we'll talk about torsion. You see, torsion is defined as gamma ijk minus gamma jik. You see, torsion free, it means that the Christoffel symbols, they are symmetric under ij and jk. So the torsion will be 0. You see, that's I said, okay, in the previous lecture, but in the next lecture 11, we'll talk about the torsion. And the torsion is related to the Lie bracket and the covariant derivative. It's a mix, you see that.